Recent trend of convolutional neural networks is very engineering things. Many people try to understand the performance of your convolutional neural network algorithm with different combinations of Béchamp and conv and ReLU layers. So for instance, for this 3x3 convolutional neural layers ResNet structure plus here. Essentially for this, we have to add some ReLU activation function and batch normalization unit. But the location of batch normalization and ReLU activation unit is not fixed. You can design residual block in this way. So 3x3 batch normalization, ReLU, 3x3 batch normalization, ReLU. This is possible, but this is also possible. Batch normalization first, ReLU next, 3x3 next, batch normalization, ReLU, and 3x3. This is also possible. Okay, so there are many different combinations. Even you can insert the residual shortcut in between here, or you can move some of the operation to here, and so on. So there are a lot of combination to define one residual block. Okay, so some researchers try to understand the order of 3x3 batch normalization ReLU can differ the performance or not. And also another interesting question is width versus depth. Essentially both are important. We need some sufficient wide network to easily discriminate the point. So recall that we need some at least 3 dimensions to discriminate the inner blue point and outer red point, right? So the depth is also very important to design nice classification algorithm. But also depth is also very important because the depth can define very complicated classification functions. So if your depth is too short, so if you just use 2 or 3 layers, the nonlinear activation function has very limited function set, so you cannot discriminate the different classes very accurately. And so both width and depth are very important. So it is very hard to know how much depth we need, how many depths we need, how many neurons we need. It is very, very difficult question before learning our algorithm. So I recommend to read the white ResNet paper. So when you search Google, the white ResNet, there are many experiments on the how to build a residual block and how to control the width and depth. Okay. Another important approach is dense block. This is also some recent research on CNN. So here, instead of use the simple residual block, 3x3, 3x3, and add. So this was simple ResNet block. But dense net structure just simply use more shortcut. So here is shortcut, another shortcut here with all the bottom layers signals. Add a lot of shortcut here. So this densely connected structure can improve the performance. That is DenseNet paper's idea. And also here is the important thing is essentially here we don't use plus operation. Instead we use concatenation operation. So concatenation means we first write down the signal from here. For instance, in this case, signal from here. First memorize the input, and then we add some additional channel and then fill with the values from the output of 3x3. Okay, the concatenation basically increase the number of the channels by stacking up the maps. Okay, so the DenseNet basically use signals of many different layers. So basically, another viewpoint of DenseNet is we can reuse the very raw informations again and again so that we can combine many different point of view of your convolutional neural net signals, which can improve the performance. So we utilize very different layer signals at the same time, and then we combine all the different layer signal at the same time, we can build much better classification function. That is the main idea of TensorFlow. So this concatenation operation is also very useful operation to design your neural network. Actually, this idea firstly used in Google Net or the Inception network. We already learned from the Stanford 231 and video.